How are you?
Right.
Good.
Alright, let's see. Looks like you got 2, right?
Actually, I don't think that's the wrong page.
Okay, which one do we want to start on here? Your dad sent like 4.
Oh, yeah, it's...
However,
I don't know if it's...
before
Yeah.
we leave that page,
Yeah,
I did notice a mistake on it. You want to go over it?
sure.
I mean, let's look at number 3.
Okay.
The slope is y2 minus y1 over x2 minus x1. So fill those numbers in for me.
Oh, okay, for number 3? Or... Okay,
Yeah. No, for y2, y1, x2, and x1.
for the third problem.
Yeah.
Okay, so it'd be 5 minus 3.
Minus a minus 3.
Or minus a minus 3, yeah.
And that's critical, because
Yeah.
that completely changes your answer. What's the bottom?
And then the bottom would be 10 minus 2.
Okay. What is that simple? What's the numerator change to?
Now it would be 8 over 6.
10 minus 2.
Or 8 minus, or 8 over 8, so it'd be just 1.
Correct. So this coefficient should be 1.
Okay.
I didn't check the rest of it.
Oh, yeah, that was, yeah, I fixed that. I think we went over this.
Well, it looks like you erased it and replaced it, but you did the math wrong in that you did 5 minus 3 instead of 5 minus a minus 3.
Yeah.
Remember that subtraction is this part. This dash means negative 3.
Okay.
So if they both are occurring, you cannot combine it into just one thing.
Okay.
You have to do both of them. Let me just take a quick look here.
Yeah, I fixed that. Isn't it y equals x minus 4?
No. Again, what is slope?
M equals y2 over y1 over x2 minus x1.
Plug it in. What are the numbers?
So it'd be negative 4 minus a minus 4 over over 3 minus 5.
Which is?
Negative 2.
Okay. What's the numerator?
It'd be 0.
Okay. So whenever the numerator is 0, the answer is 0, regardless of what the denominator is.
Yeah.
Okay. So y minus y1 equals 0 times x minus x1.
Yeah.
That means when you solve that, y is equal to y1.
Okay.
That's the answer. Y and y1 is minus 4. Y equal minus 4 is the answer. In other words, there is no x term because the multiplier of x is the slope. And we got a slope of 0.
Okay.
Okay, and let me just quickly check the last one. We've got 8 minus 3. You got to pay attention to the direction of the signs here.
Okay.
What is y2 and y1 here?
So y2 would be 8 minus 3
Okay, that's the numerator. What's the denominator?
6 minus 9.
Okay, and you got to go in the same direction.
Yeah.
You could have done 3 minus 8 divided by 9 minus 6. That's okay. But you can't not go in the same direction. Well, what's that equal to?
And then that's equal to 5 over negative 3.
Okay, so that's the slope, minus 5/3.
Okay.
So your answer is going to be y equals minus 5/3 times x and all the rest. And not that all the rest is insignificant. Is this something you have to turn in still?
Yeah. Yeah, I
No,
fixed
we
those.
better get it right then while we're looking at it, don't you think?
Yeah.
I mean, this is as good a place to
And then,
start as any. Hold on.
yeah. Okay.
Let's make sure we get them all right here. Let's go back and
Okay.
look at this one.
Okay.
So we know that y minus y sub 1
Mm-hmm.
equals 1 times x, y minus y sub 1, which was minus 3. Again, we've got the negative, minus a negative number, times x minus 2. I'm going to use this point here, x1 and y1.
Okay.
Okay? And now if you solve that, it's y plus 3 equal x minus 2, or y equal x minus 5. So that's the answer for 3.
Okay.
Okay? To me, it's easier to use point slope
Mm-hmm.
and then convert rather than have to solve for b.
Okay.
We don't have to solve for b if we use point slope.
Okay.
So, what did we figure the slope of this was? 0, and that's just y equal minus 4.
Minus 4, yeah.
Okay? This one is y equal, y minus, let's see, which point shall we use? How about 6 and 8? So y minus 8 is going to equal the slope, which we found to be minus 5/3 times x minus 6, correct?
Yeah. Mm-hmm.
Okay. And they want it in slope intercept, so we can't give this as an answer, but we can start it in point slope and then simplify. So simplify this for me.
So it'd be y minus 8 equals negative 5/3 x minus...
You're multiplying a minus times a minus.
Yeah, so it'd be plus 10.
Good. And now the last step.
And then... What do you do?
Trying to isolate y.
Okay, so you add 8 to both sides.
Okay.
So now it'd be y equals negative 5/3 x minus, plus 2.
All right. Let's go back and do it the way I should have
Plus 8, yeah.
done it this way.
Yeah, so it'd be 18.
Okay. You're going to have to do it this way until, however long it takes, until you stop doing what you do if you do it the other way.
Okay.
Okay? And who knows? Maybe that's 3 years.
Yeah.
But maybe it's only a month, and then you can stop having to write it on both sides.
Okay.
But it's still enough of a problem where I think you should write it on both sides. Okay? So that's your answer for that one. Okay, now we can go to another sheet.
Okay.
And let me put that aside. Now, I may not have the order of these right. 4-1.
Actually, that's the wrong one.
3. Let me open up this one. This might be 4-1.
Okay.
No, this is 4-6.
Yeah, that's not it either. It's a yellow sheet. I don't know if it turns out yellow on. Yeah, that's it. Yeah.
Okay.
Cool.
Yeah. Yeah, this is kind of the stuff we were getting into the other night.
Yeah, systems of linear equations.
Yeah. Tell whether the ordered pair is a solution of the system of linear equations. Now, that does not mean no solution. In other words, first of all, when you look at a system of linear equations, there's 2 of them, that makes it a system. Sometimes there's actually no solution, but this isn't one of them. Notice I can add these two equations, and what do I get? 4x equal 8. That makes x equal 2. Y must be 6. That has a solution. 2 comma 6.
Okay.
Okay? Now, what she wanted as an answer here was yes or no, not no solution. No solution has a very specific meaning. It means that there is no solution at all. What she wants to know is this a solution?
Okay.
Okay? And the way you tell isn't by solving it. It's by substituting.
Okay.
In other words, take that x and y point and substitute it into the first one. Does it work?
Yeah.
2 plus 6 is 8. Substitute it into the second one. Does it work?
3 times 2 is 6, minus 6 is 0, so yeah.
So the answer is yes. If it works in both, then the answer is yes.
Okay, cool.
Okay, and we don't have to actually solve that. This is kind of Systems of Equation 101. This is the very, very basics.
Okay.
Let's substitute it here and see if it works.
Okay, so 8 minus 2 is 6.
Okay.
And then 2 times 8 is 16 minus 20.
Okay.
So no, that wouldn't work.
Okay, so no is the answer here.
Okay.
Let's try it over here.
Okay. Okay. So
Substitute it in. So what should I write?
so for y equals 2x plus 6, you put in a negative 2 in place of y.
Yep.
So it'd be negative. So 4 times 2 is 8 plus.
Is that true?
So 8 plus. Yeah, that is true. No. Wait. Yeah, no, that's not true.
Okay. So that's a no also.
Yeah.
And it's all you have to do is find that it doesn't work in one of the equations, and it's not a solution. You don't even need to test it in the second one. In fact, I'll bet it probably works in the second one. Let's see if it does.
Okay.
Minus 2, is that equal to minus 3 times 4 minus 14? Yes, it is. No, it isn't. Excuse me. Wow. And I think I never make a mistake. That's minus 26.
Okay.
So it's not even true in the second solution either.
No.
So we got a yes, no, no. Okay.
Okay, cool.
Solve them by graphing them. Okay, let's see. You probably should label these.
Okay.
Just because we don't know. I can't tell whether you've done it right, really. I guess I can. Let's see. I can tell that the one with the positive slope is that one, and that looks correct. And the one with the negative slope is that one. I'm assuming that's 1, 2, 3, 4, 5, 6, 7. Okay, that looks correct. It's got a negative 1, so they intersect where? At 3, comma 1, 2, 3, 4?
Yeah, 3, 4.
So 3, comma 4 is the answer. In other words, this doesn't complete it. You have to actually read your answer off your graph and put it in parentheses 3, comma 4.
Okay.
Because it does say solve it. Now, even though you're solving it by graphing, she wants an answer, a number answer also.
Yeah.
Okay, let's look at this one. The only way you can solve it by graphing is if you intersect the two lines.
Okay.
You can't come up with a solution unless they intersect. If they're parallel, then there is no solution.
Yeah.
Okay, these two are not parallel though. Notice this has a slope of 1/3, this has a slope of 2/3.
Yeah, so they're not, but they're both not the same.
Which means they are going to connect. Now, they're so close to the same slope that they're going to connect somewhere over there, but you need a straight edge to draw this.
Okay.
Okay, put a straight edge on your points, draw a straight line, do the same for that, and they'll likely connect somewhere like there.
Okay.
Let's see if I can solve it in my head. 1/3 x equals 3. 1/3 x equals negative 3. Therefore, x is negative 9. So it's going to intersect over at about right there if that's negative 9.
Okay.
And hold on, I'll give you the y-coordinate. The y-coordinate's going to be minus 1. So the intersection point is right where my hand is. Minus 9 minus 1. And just to show you how I got that, you still need to do what the problem requests, which is to graph it and figure out that they intersect at that point. But here's what I did. I put the bottom equation on top.
Okay.
I put the top equation on the bottom because I want to subtract them. Notice that when I subtract them, I'm going to get all positive numbers. Y minus y is 0. It doesn't have to be in standard format in order to do this. 2/3 minus 1/3 is 1/3. 5 minus 2 is 3. Now I move the 3 to the other side. Multiply both sides by 3. And that's how I get x equals minus 9.
Okay.
I plug in minus 9 for that, and I get minus 3 plus 2, y is equal to minus 1.
Okay.
So that's solving it algebraically. I didn't look at the graphs to solve it. I just did subtract the two equations from one another. And I knew that y would disappear. She wants you to do it graphically. So, okay, so this one over here, these two equations are in what kind of format?
Standard form.
Okay, when you're in standard format, it is particularly easy to graph.
Okay.
More so than any other format. Believe it or not.
Okay.
Easier than slope-intercept, I think.
Yeah.
The reason is that you only need 2 points on each one. You need the x-intercept and the y-intercept.
Okay.
Okay? On the first equation, the x-intercept comes when y is equal to what?
3.
No. Think about it. Think about it. If I draw a line, what is y?
Negative.
What is y at that x-intercept right there?
Negative 3.
No.
Oh.
No, hold on. This is the x-axis. This is the y-axis.
Oh. So it'd be 9?
Be 0.
0.
What is
Oh, because, yeah,
y?
0's on the...
In other words, that might be 9 comma 0, but the y is always 0.
Okay.
That is the definition of x-intercept.
Okay.
In the same way that the definition of y-intercept is what? What is x when I'm on the y-axis?
0.
Exactly. That's a huge thing to memorize and remember.
Okay.
Is that when you're talking intercepts, you get the x-intercept by setting y equal to 0, and you get the y-intercept by setting x equal to 0.
Okay.
Okay? So, with this problem, 9x plus 3y equals minus 3. Tell me what the y-intercept is.
The y-intercept would be 3.
No. Set x equal to 0 and solve what's remaining.
3y is equal to negative 3.
So y is equal to what?
So y would be equal to negative 1.
Okay, that's the y-intercept right there.
Okay.
What's the x-intercept?
And then the x-intercept would be negative 3.
No, do the math. Don't just, in other words,
So,
do it on paper if you have to. You
Yeah.
reverse stuff a lot. And the only solution for that is to do it on paper.
Okay.
When you solve for x, when you set y equal to 0 and solve for x, what do you get?
Wait, when you set x to
That's
0.
y equal to 0. No, we've already solved for the y-intercept, which is setting x equal to 0. Now we want to solve for the x-intercept. We're going to set y equal to 0.
Y equals 0.
Which means you end up with 9x equals minus 3. Now be very careful about doing that. Solving
Okay,
it.
yeah.
You tend to
Oh.
want to make that answer -3, and it's not -3. What is it?
So you divide by 9.
Exactly.
So it'd be -1 over 3.
Right. So that's the x-intercept right there.
Okay.
-1/3, comma 0. And this one was 0, comma -1. Notice I don't have to find slope. I've got my graph now by just connecting those 2 points.
Yeah.
So let's do the same process on the second function.
Okay.
2x minus y equals -4. Tell me what the y-intercept is.
Okay, so you'd replace 2 with 0, so...
Not 2.
Or x with 0.
Okay.
So 2 times 0 is 0. So it'd be y equals -4.
Hold on. Don't drop the minus sign.
Or negative y equals
Negative y equals
4.
-4, so y is equal to what?
Y is equal to 1.
No. How do you
Or
solve
4.
this equation? Y is equal to 4. I divide both sides by -1.
Okay.
Okay?
Okay.
And think about it. We got to have y equal to a +4 because then -4 would be equal to -4. If I make y anything other than a +4, in other words, that has to be a +4, then this is not going to be a correct equation. But the real way we're solving it is dividing both sides by -1. Okay? So now I know my y-intercept. Right there. That's at 0, comma 4. What's the x-intercept?
Yeah. Okay, so now you would replace -y with 0.
Okay. So now you have 2x
And then, so it'd be 2x equals...
4.
Okay, and then you divide by 2.
Okay.
So x is equal to -2.
Okay. I think a lot of times you just go too fast. I really do. I really think that that's a lot of the problem. Let's see, that's the x-intercept, so that is -2, comma 0. And now we can connect those 2 points, and there's our answer right there, whatever that is. And since I don't have a grid, I can't tell, but that's what you need to do on your grid.
Yeah.
Now, I can solve this. I can tell you what that point is. It'll be helpful to know what that point is. In fact, let's get you started doing this also.
Okay.
Let's solve this by elimination, because even though this is first steps of getting to solving it by elimination, it's coming real soon for you,
Yeah.
if it hasn't come already. Have they done solving by elimination yet?
They haven't, no.
Okay, but they will, I guarantee you, within the week.
Yeah, they probably will. Yeah.
Will anything be eliminated if I add or subtract them?
No.
What do I have to do to one of the functions so that something will be eliminated if I add or subtract them? What could I do to the bottom function?
Yeah.
It's not going to be easy to eliminate the x, is it?
No.
Because 2 doesn't go into 9. I'd have to introduce fractions.
Yeah.
But it's going to be quite easy to eliminate the y. What do I have to make the bottom function have in front of this coefficient?
3.
Okay, so how do I get that?
You would... What would you do? You would add... No.
No. You can multiply both sides
Yeah,
of the
you can
equation
multiply.
by 3.
Yeah.
Okay, well, if I multiply that whole equation by 3 and this whole thing by 3, what do I have? I have 6x minus my 3y, that was what I was looking for, equals minus 12. And now let's erase that one because it's just in the way now.
Yeah.
What we're really going to do is add these two. What do you get?
Okay. So So you get 3x
No.
is equal to...
Hold on. We're adding them.
Oh, yeah. Okay. Oh, okay.
Because
Okay.
only adding them will eliminate the y.
Yeah.
If this was
Okay.
a positive 3y, then we'd subtract them.
Mm-hmm.
But since it's a negative 3y, I need to add these two together to get y to go away.
Okay.
Okay, so what do we get?
So you get 15x is equal to negative 15,
So x is equal to what?
negative 1.
Okay. And let's see, if I plug in a negative 1 here, I get negative 6 minus 3y equals negative 12. So I get minus 3y equals negative 6. Y equals positive 2.
Okay.
And it looked like it was intersecting above the x-axis. So that sounds right. X equal minus 1, y equal 2 is your solution. And that's where your two lines should end up crossing. If they don't, you've graphed them incorrectly.
Okay, yeah.
Okay, that's in other words, all of these methods of solving these have to agree.
Okay.
Our graphical solution has to agree with what we see. Our method of elimination has to agree with our graphical solution. And if we were to solve these by substitution, that would have to agree with both the other two.
Okay.
All right, we've got 3 minutes, and unfortunately I have an appointment at 6:30, so I don't have extra time. What would you like to do with that 3 minutes?
Let's try to do a little of number 7.
Okay. You have 40 minutes to exercise. You want to burn 300 calories. You burn 8 calories per minute. And 6 calories per minute using the stationary bike. How much time should you spend on each machine? What's the first step of any word problem?
Underlining like important,
No?
like info.
Very, very important. If you remember this, you'll be good at word problems, and nobody's good at word problems because nobody remembers this.
Yeah.
Seriously, if everybody
Yeah.
remembered the first step, then the word problem would flow.
Okay.
The first step comes from the last sentence. How much time should you spend on each machine? In other words, the first step is define your variables and say what they mean.
Okay.
Okay? How about if we make X the number of minutes on the elliptical trainer?
Yeah.
And let's let Y be the number of minutes on the stationary bike.
Okay.
Okay, now that we've done that, we can go back and look at the problem and reread the questions and translate them into equations.
Okay.
You have 40 minutes to exercise. What does that mean?
That you, well, yeah, like that you only
Make
have 40 minutes.
make an equation out of that. If
Okay.
X is the number of minutes I'm going to be on the elliptical and Y is the number of minutes on the stationary, what's the equation that comes out of that first sentence?
So you remember Y equals,
X plus Y equals 40.
okay, yeah.
That's straightforward. Okay? Now, it says you burn 8 calories per minute on the elliptical. Well, how can I write that in an equation?
8x,
Good. Plus,
so 8x, plus
I burn 6
6x.
calories on the stationary. The stationary is Y.
So plus 6y.
And what do I want that amount to be? That's going to be the total calories I'm going to burn, right? In other words, if I burn 8 calories per minute and X is the number of minutes, then 8 times that. If I spent 20 minutes on this, it would be 8 times 20 plus this. So that's the total calories burned, and they've told us that that's supposed to be 300. So I'm going to substitute 300 for that. Now look at what I'm looking at. A system of equations.
Okay.
Which you can solve in multiple manners now.
Yeah.
You could multiply the top by 6 or 8 and then subtract the two functions.
Mm-hmm.
That would eliminate a variable.
Hey,
A variable.
Don't ask him if he has a 6:30 appointment. Ask him.
I do. I do, Mike?
Yeah, I told him, yeah.
Okay.
Okay.
And I will leave you at that.
Okay, cool.
All right. Bye-bye.
Okay. All right, thanks.
Talk to
Bye.
you tomorrow. Bye-bye.
Okay.